Hey everybody. Today we're differentiating trigonometric functions. The two most basic trig derivatives are these. The derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. Don't forget that negative sign. Each of these identities can be proved using the definition of the derivative and the limit rules for sine and cosine. I don't think the proofs are that interesting though, so I'm just going to show a couple of pictures. Here we see the graph of the function y equals sine of x, and its derivative y equals cosine of x. The function sine is in the solid red, and the derivative cosine is in the dotted yellow. So notice at pi over 2, sine has a horizontal tangent line, and cosine is 0, has an x-intercept. Similarly, at x equals 0, for instance, you can see the sine graph has a tangent line of y equals x, slope of 1, and the cosine function has a value of 1. Similarly, here are graphs of y equals cosine of x and its derivative, y equals negative sine of x. And we can make very similar observations as we did for sine of x. At x equals 0, for instance, cosine of x has a horizontal tangent line with slope 0, and so the value of its derivative is 0. Negative sine of 0 is 0. The derivatives of other trigonometric functions are just based on those two most fundamental formulas. For instance, we can do the derivative of tangent of x by differentiating sine of x divided by cosine of x, just using the quotient rule. We do low d high minus high d low, draw the line, square below. Notice that the numerator there is cosine squared plus sine squared, which is 1. So 1 over cosine squared, also known as secant squared. We can do similar things for cotangent as well as for secant and cosecant. Here are all 6 trig differentiation formulas. The 3 that I already mentioned, plus the derivative of secant x is secant x tangent x. The derivative of cosecant x is negative cosecant x cotangent of x. And the derivative of cotangent x is negative cosecant squared of x. The first 4 of these come up the most frequently, and so they're the most important to really have memorized. Okay, let's do a few quick examples. Differentiate x to the 5th times tangent x. This is going to be a product rule. We do the derivative of the first times the second, 5x to the 4th tangent x, plus the first times the derivative of the second, x to the 5th times secant squared of x, using the fact that the derivative of tangent of x is secant squared of x. Example 2. Differentiate sine x plus cosine x over cosecant of x. So this time it's a quotient rule, low d high minus high d low, draw the line, square below. The derivative of the top is cosine x minus sine x. The derivative of the bottom is negative cosecant x times cotangent x. Overall, here's the answer I get. And this could be simplified a little bit, but I'm not going to bother to do that just now. Example 3. Differentiate secant squared of cotangent of theta with respect to theta. So this one requires the chain rule. If you haven't gotten to that yet in your calculus class, this is a good one to come back to in a section or two. Let's run through it though anyway for those that have. We differentiate from the outside in. First we differentiate the square, then the secant, then the cotangent. So 2 secant cotangent of theta, that's differentiated in the second power, times, now we're differentiating the secant, secant of cotangent theta times tangent of cotangent theta. Finally, we multiply the derivative of the innermost function, cotangent theta, and the derivative there is negative cosecant squared of theta. Overall, 2 secant of cotangent theta times secant of cotangent theta times tangent of cotangent theta times negative cosecant squared of theta. Again, there's at least one fairly simple way where we can simplify this, and I'm just not bothering to do it in this video.